In this lecture, we will talk about Kiali. Once you have many microservices, it is important to observe them and check them to make sure they are available as you configured them. Kiali is a very common and powerful add-on used with Istio. It has a web-based graphical interface. It is a very helpful and fun tool for visualizing and managing service mesh. For now, we will go over a high-level overview as it will help us visualize everything we will learn in the initial chapters. Later on, we will go into details of Kiali in the observability chapter. Kiali is used for observing connections and microservices of Istio service mesh and also for defining and validating them. It visualizes the service mesh topology and provides visibility into features like request routing, circuit breakers, request rates, latency, and more. Kiali also offers wizards to apply common traffic patterns and automatically generates Istio configuration. After we install Kiali, we will also generate some test traffic to make sure we can see it on the Kiali dashboard. Let's dive in and see how to install the add-on and view the Kiali dashboard. Now let's install Kiali on our cluster so we can visualize our service mesh. Let's use this command to install and see all the add-ons that are provided in the samples folder. We will talk about more of these tools in the observability chapter again. As you can see, Grafana has its service account and a set of config maps and deployment, and Jaeger is also installed from the add-ons, and we will talk about it in the upcoming chapters. Then there is a large group of objects that has come with Kiali installation. Then at the very end, you can see Prometheus also installed. An important note is that these add-ons are not tuned for performance and security. These are meant for only demo purposes. So, let's check the status of our Kiali deployment. Yes, it has been rolled out successfully. And let's verify if the Kiali service is running. You can use this command if you need to check Kiali is running or not on your cluster. And now, with this command, we can start Kiali dashboard. It will start a browser and land on the overview page. In the address bar, you can see it is being served on the port 20001. On the left menu, you can see different levels of visualizing your mesh, and on the top left, you can change the type of filter that you can use. On the far right, you can filter your whole mesh by time intervals, and next to it, you can change how often you need your data to be refreshed. Now, here are all the namespaces in our service mesh. You should be able to see all that. When you click this number next to the applications, it will take you to the applications page, which is also accessible from the left. Here you will find our 4 applications from Bookinfo. You can always jump to some other namespace to see what's going on there. If you go to the workloads from the menu, you will see all our different deployments listed as workloads. Now, let's check services. There are no services, which is weird. Sometimes it takes a while to load all the service mesh applications and objects. Yes, they are here now. And when we go to the istio config menu, we will see nothing because we actually don't have any istio configurations for this namespace yet. And the last bit, but a very powerful tool, is the graph menu, where we'll have most of the fun. We see this is also empty because there's no traffic right now. Now let's start creating some traffic to visualize here. To see some real action in Kiali, our application needs to accept some traffic first. Let's do this together now. Let's create a gateway for our application. We will cover this topic in our next chapter, and all you need to know right now is that Gateway will configure our service mesh to accept traffic from outside the cluster. In order to do this, we'll use the bookinfo-gateway.yaml in the networking directory. There's also a virtual service in the sample file, and we will talk about virtual services in our traffic management chapter. Let's check if everything's alright with our mesh. There's no validation issues. Let's find out at which IP our local cluster is reachable. Now, we will export this IP to a variable to use it more efficiently. Depending on your local cluster, you may export this IP with a command like this. Let's check it. Yes, it's set. Let's also get the proper port numbers with this command from istio ingress gateway service. Let's check if the port is also set. Now, we can curl the product page using this address from our terminal. You can see it works. The whole HTML code of the product page is printed out. We can now also try to reach the Bookinfo app from our browser. To do that, we can get the URL easily by removing the curl from this command. Here, let's try this. Yes, our app is up and running. And every time we refresh it, the color of the stars are changing, so it also shows that our app uses 3 different versions of reviews right now. Now, let's create some more traffic into our service mesh because it will be much easier to experiment with it when we don't need to make requests to our app one by one through curl or from the browser. For this, I use this very simple command that creates a loop of curls to the product page. And I did not get the output of the curl printed on the terminal, which might look very crowded. And please take care of the backslashes in this command. Sometimes while copying, it could get messy. Now, let's go to the Kiali dashboard to see if we'll have any real action. It usually takes some time for Kiali to gather all the data and visualize it, so it might be helpful to change the time interval and refresh the graph a few times. As you can see, it is coming all together. Yes, it now looks exactly like we've been expecting it to look so far. And from the menu, we can see the applications are all healthy, workloads and services as well. Let's check what we've added as istio2 with the bookinfo-gateway.yaml. Here is the bookinfo-gateway and bookinfo virtual service. These are the only istio configurations we've done so far. In the next chapter, we'll cover both of these in detail. Kiali is very helpful in identifying problems in service meshes. To create some actual problem, let's delete one of our deployments to see what will happen. Okay, that's a very nasty thing to do. Now, moving to Kiali dashboard, let's wait to see the impacts of our change here in the graph. Yeah, in the graph, we can see product page going into a half unavailable, half available state, which is because the last 1 minute interval still holds the data from the time product page was working, and then it is marked totally in dark red, which can also be seen at the bar on the right, because now all of the requests are getting 500 errors. And in the applications menu, product page has no health information, and since we deleted the deployment, it has totally disappeared from the workloads. Once the product page is gone, none of the services are receiving traffic from our curl loop. This can also be seen in the services page with question marks in the health column. We don't have any information about the health of those services anymore. Let's briefly recap about Kubernetes services. So pods, as we know, are the smallest deployable units in Kubernetes. If you want to run something on Kubernetes, you need to create a pod and place the application in it. Pods are ephemeral, which means they can be created and killed to match the cluster state you declared via deployments. We need our pods to find each other and communicate within the cluster, so our application can work as expected. Pods, however, have their own IPs, which is good, but IPs keep changing because pods are, well, ephemeral. So, how do I find my application's pieces in a cluster and help them communicate? Like, let's say a front-end service talks to a back-end service, while these IPs are changing all the time. This is possible via Kubernetes services. A backend service can be created to point to the backend pods so that any other application within the cluster can use the service to to reach the applications in the backend. The service has its own IP, and so we no longer have to rely on the IPs of the individual pods. Services are an abstraction that determines which pods to connect to and a policy on how to connect them. Pods have labels on them so that our service can select them in a huge pool of other pods. There are three types of services in Kubernetes: node pod, cluster IP, and load balancer. The default type of service is called cluster IP. This is an internal-only service that is created to enable communication between applications within the cluster. This type of service is only accessible within the cluster. If you'd like to make an application accessible outside of the cluster, then you must create a service of type node pod. This will make the service accessible on a predefined pod on all the nodes in the cluster. The third type is called load balancer. This type of service is only supported with specific cloud providers. This is like node pod service, but invokes a supported external load balancer to create a load balancer to the ports the application exposed on the nodes in the clusters. That's a quick recap of services. We talk more about services and how to create them in the Kubernetes for the beginners course. During the course of this training, we will be mentioning sidecars a lot. So let's quickly brush up what those are. Have you seen the small passenger cabins attached to the motorcycles? They're called sidecars. I always dreamt of traveling inside one of them when I was a kid. In the Kubernetes world, we know containers are encapsulated into pods. Each pod can have one or more containers. The additional containers that support the main container are called as sidecars or sidecar containers. They share the same volume and network, but they have different responsibilities. Sidecars are responsible for log shipping, monitoring, file loading, or in our case, proxying, and they are relatively small in size. Our main container handles a business logic, a functionality that adds value to our application. Sidecars help in isolating these functionalities from our business logic. Here's a sample pod definition file for a sidecar container. Under Containers section, first we have an Nginx container, which uses the Nginx image. Then we have a second container, created with a FluentD image, which is our sidecar container, responsible for shipping logs of the main application to a central server. So that's a sidecar container. Next, we will talk about Envoy. When you get into the service mesh world, Envoy is one of the most common proxies you'll hear about. So let's have a look at it now. Envoy is a proxy. But what is a proxy? Let's forget about containers and Kubernetes for a second and talk about a user trying to connect to an application. The application currently has its business logic. That is, whatever the application does, and at the same time, also does other things, such as securing connection using TLS encryption, or authentication, or retrying requests if it is not able to serve the user, etc. These will need to be coded into the application. What if all of these extra functionalities could be outsourced into a separate service so that the developers could focus solely on developing business logic, which is more fun? That's called a proxy. Now, the user reaches out to the proxy, and the proxy forwards the request to the application. Envoy is an open source proxy designed for modern service-oriented architectures. It was mainly started in the company Lyft in 2015, when they were trying to solve their own microservices problems. So, it was mainly designed for distributed architectures and microservices. In 2017, the project was accepted to CNCF. And in 2018, it reached to the graduate level, which means it is battle-tested, ready for production, and has a healthy number of contributors. Envoy is a proxy and communication bus with advanced capabilities. It works as a sidecar next to your containers, just as we described in the last slide, so that the traffic going in and out of our pod is using Envoy as a proxy. Many service mesh implementations use Envoy now, and we will talk about Envoy more in Istio's core architecture.